Hello students, welcome to Power Tutorials. So today we are going to cover part 3 of chapter 9, which is light chapter with reflection and refraction of CBSE class 10 of science textbook. Okay, and we are going to cover the board which is 2025 to 26. So who are going to write their exams for 2026 board exams. So in the previous parts, that is part 0, part 1, 2, I will go give a synopsis what I have covered. So in part 0 I have covered what is how an object can be seen, like what is the color of a mangrove, why you are only able to see the yellow color, that we have covered, and why we are not able to see any objects inside a cave, what is the reason, what is a mirror, we have covered basic definition, types of mirrors, plane, spherical, and why, what are the sphericals, like why it, which is called concave and why it is called concave and why it is called convex, parts of a spherical mirror we have covered, and then reflection basic definition we have covered, like the basic rules of reflection, incident ray, reflected ray, and normal. And then we have covered the basics of refraction, and we also covered what are lenses. So in that part we have covered the basics of, I can say, like a prerequisites for this chapter. Okay, in the part 1 we have covered what is a plane mirror in detail and what are the basic details, like what is the distance of object from the mirror and how the image creation can be formed. And then we have covered in definition exactly like how we have to write to get good marks. At the same time we have to, if anyone asks what should be the exact laws of reflection. And then spherical mirrors we have covered, and then convex, concave we have covered, and the points to with respect to spherical mirrors for ray diagram we have covered. And after we have started with images creation for concave mirror. So in part 1 those are done. In part 2 we have started with concave mirror. We also covered the uses of concave mirror, and then we have covered the images formed by the convex mirror with respect to the position of the object in front of it. Okay, and then we also covered the uses of convex mirror, and then sign convention for the reflection of spherical mirrors, like we have a mirror formula which is 1 by u plus 1 by v is equal to 1 by f. So at which scenario u will be negative, v will be negative, and f will be negative, those we have covered. And we have covered the magnification formula as well. Magnification formula is the size of the image changes, like what is the ratio between the height of the image by height of object. And then we have one more formula which is minus v by u. Minus v is the distance of the image from the pole, and u is the distance of the object from the pole on the principal axis. So those we have covered in part 2. So in part 3, so today we are going to cover mainly like what is refraction, and we are going to understand few terminologies related to it. Okay, so before going to the refraction definition, I just everyone like who is watching this video, I just want everyone to try this experiment in your home because it is a basic. So what you have to do is take a jar, and preferred it should be a glass jar made of glass. Okay, so keep one pencil or pen, make sure it is not open like this in the image, so make sure it is like a closed pen or pencil. Keep it on the empty glass jar first, and watch how we are able to see the pencil. Okay, in the second step, now take a jar with water or fill the same jar with water. Like this shown in the image. Now again keep the pen or pencil and see the difference. From the side view, if you notice, this side will be straight, but from after the point where it is inserting into the water, you can see that it is a slight disturbance, like you can see the pencil has been moved to some distance. Okay, so this is simply the refraction. Okay, now we will understand what is the definition. So what is refraction means? Bending of light rays. Bending of light rays. So when it is bending, when it is traveling from one medium to other. So what is medium here? Medium is the like environment to which it is happening. So here I can say we have two mediums. First medium is air, and the second medium is water. So it is traveling from medium 1 which is air to medium 2 which is water. So we are able to see this object through two mediums. One is to air and to water. So what is happening once it is the pencil or the light ray using which we are able to see this object is getting changed. Why? Because from medium 1 it is changing to, the light has to travel through medium 2, but as it is traveling to two different mediums, I can say there will be a bending of light. So why there will be a bending? That is the main question. So what is refraction we understood, but why is refraction? Why it is happening? It's not like we are studying, but you should also understand why it is happening. Why it is happening? Because due to change in velocity of light. So I am talking about the velocity of light. So I think everyone knows what is the velocity of light in vacuum. So velocity of, okay, I will add one more slide. So we'll, sorry, just okay. So what is velocity of light in vacuum? Velocity of light in vacuum, and I'm sure everyone might have studied in your previous classes. This is very important value. The answer is 3 into 10 to the power of 8 meters per second. Okay, so what is velocity of light? This value you have to remember. So what is velocity of light is 3 into 10 power of meters per second, and this is the highest velocity through which we are talking about all the types of air, vacuum, or even sound speed, everything. So light speed is considered the highest speed. Okay, so what is that value in vacuum? That is, if it is no air or anything, the value is 3 into 10 to the power of meters per second. So what happens when the speed of light, the velocity of light, if it is in air? So here, if it is vacuum, it is exact 3 into 10 power of 8. If it is vacuum, it is closer to 3 to the power of 8. So maybe 2.998, something like that. Okay, but the same velocity will get even decreased if it is traveling through water, or if it is traveling through even glass, if it is traveling through diamond, and if it is traveling to other oils like kerosene. So what is happening? The velocity of light is getting changed when it is traveling through different mediums. So as the velocity of light is getting changed, due to which till here we are able to see like a straight, but after that it is getting changed. Why? Because the velocity of light is changed. As the velocity of light is changed from one medium to another medium, we feel that it is bending. Okay, hope everyone understood why there is a reflection and what is refraction. What is refraction? It is a bending of light from when the light is traveling from one medium to other. And why it is happening? Because there is a change in velocities with respect to light from one medium to another medium. Okay. Now we'll study about loss of refraction. Okay, it's not reflection. Reflection loss we already studied in part 1. Now we're going to study loss of refraction. So the first point is incident ray, refracted ray. It's not reflected here, it is refracted ray, and normal to the surface. All should lie in same plane. The second point is important because it's the difference between reflection and refraction. Here, the ratio of sine, I think everyone knows what is sine. We might have studied in trigonometry in the previous classes. So if not, also you will understand. So we have a trigonometry ratio, sine, cos, tan and all. So just remember, sine is one of the trigonometry identity, trigonometry ratio. So what it is saying is ratio of sine of incident ray to sine of refracted ray with respect to normal is constant. And it is constant for what is also important. is constant for light of given color and given pair of medium. For given color and given pair of medium. Pair of medium why we are talking about, because for refraction there should be having at least two mediums, where when it is traveling from one medium to another medium, how it is changing, that is nothing but refraction. So you should have a given pair of medium and given color, then the sign of incident, the sign of refraction will always be constant. So how they are saying is, suppose we have like this is air and suppose this is water, okay, and this is medium 1, medium 2. So suppose we have a light ray like this, incident rays like this, then suppose we have a refraction. So incident ray should be something like this, and refraction I am assuming it is something bended like this way. Okay, so with respect to normal if I draw, then this is incident angle which is I, then this will be refracted angle which is R. So sine of this I by sine of this R will be constant. So now I have drawn like this. Now suppose this is I1 and this is R1. Same mediums I will take and same light I will take, but I will just change the angle of the incident ray. Let's suppose I am having the incident ray like this. Okay, now this is incident angle. So instead of moving in this way, so assuming that light ray will travel like this. Okay, now we have this is refraction. This is R2 and suppose this is I2. Then sine of I2 by R2 is equal to sine of I1 by R1, and that value should be constant. Hope everyone understood what is second point. Ratio of sine of incident angle with respect to normal by sine of refracted angle with respect to normal should be constant, but under what condition? It should be having same color and same pair of medium. Okay, here we are talking about air and water, and here also should be air and water. Then only this law will satisfy. And this ratio is, this point is also called as Snell's rule or Snell's law. So what is Snell's law? He is saying that ratio of sine of incident ray to the sine of refracted angle, sine of incident angle is by sine of refracted angle is always constant for given color of light and given pair of medium. Okay, these are the laws of reflection. So now we'll study about another topic which is refractive index. So we just talk about what is how the refraction is happening. It is happening because of the change of velocity of light difference from one medium to another medium. Same way, if we talk about what is refractive index, means refractive index of 2 with respect to 1. Okay, it's a relative quantity. Why it is a relative quantity? Because we have to give the refractive index based upon one medium to another medium. Thus way it is a relative quantity. It's not like we have a speed of light in vacuum is 3 into 10 power of 8. But if I say what is the speed of vacuum with respect to another speed of light in air or speed of light in water, that is nothing but refractive index. Okay, so refractive index is a relative quantity which is having the ratio of two velocities of lights in two mediums. Okay, so now if I say what is refractive index of 2 with respect to 1, then the ratio will be velocity of light in 1 by velocity of light in 2. So I am talking about velocity of light in medium 1 by velocity of light in medium 2 is nothing but the refractive index of 2 with respect to 1. Okay, so the refractive indexes for air, if I ask you what is refractive index of air, then I can say it is velocity of light in vacuum by velocity of light in air. So always remember, velocity of light in vacuum is the highest value, which is 3 into 10 to the power of 8 meters per second. But with respect to mediums, it will keep on decreasing, but with respect to air, it is almost equal. So thus way the velocity refractive index of air is considered as 1.00, I think it's 1.0002. Okay, I will just cross check in the next video, but it is almost equal to 1. Why? Because velocity of light in vacuum and air are almost same, which is 3 into 10 to the power of 8 meters per second. Okay, so with respect to glass it will change, with respect to kerosene it will again change, and with respect to diamond, if I ask you what is the refractive index of diamond, its value is nearer to 2.5. Okay, so you can understand that velocity of light in diamond is much smaller when compared to velocity of light in vacuum, thus the ratio is higher. Okay, let's see this question. What happens when light ray travels from rarer to denser medium and vice versa? Vice versa in sense, if it travels from denser to rarer, what will happen? Okay. So let's see the first condition, when it is moving from rarer to denser. Rarer to denser is the one which I already covered, which is from air to water. Okay, so we have, suppose we have incident ray like this. This is normal. This is incident ray. For water, it will try to move towards the normal. This will be R and this will be I. So what is happening here? The light ray is moving from rarer to denser. If it is moving from rarer to denser, what will happen with respect to velocity? Velocity decreases. If velocity is decreasing, you can see here, instead of going in this way, it is moving towards normal. So if a light ray is traveling from rarer to denser, what will happen? The refracted ray will travel towards normal. Okay, so this is very important, and this can ask you for a question for 1 mark or 2 marks, and they can also ask you, give the reason. They will simply say that I am traveling okay, I have a light which is traveling from air to water. Then how it is bending? Is it bending towards normal or not? If yes or no, give me the reason. Then you have to say that if it is traveling from air to water, then the light ray is traveling from rarer medium to denser medium. So if it is traveling from rarer to denser medium, what is happening? The velocity is getting decreased. If velocity is getting decreased, it will try to have travel towards the normal or closer to the normal. Okay, the same thing if it is an opposite, denser to rarer. So for this, what I have to do? I have to keep the first medium as denser. So here I am keeping this as water, and from here it is traveling towards air. Okay, so I have water here, and I am passing a light ray from this medium to water medium to air. So this is normal. So if I travel like light ray from water to air, what will happen is, instead of traveling towards normal, it will go away from the normal. Okay, this is the refracted ray now. This is I, this is R. Now you can see the refracted ray angle is greater with respect to incident angle. Why? Because it is traveling from denser to rarer. So if a light ray is traveling from denser to rarer, what will happen? Velocity increases. Okay, velocity is increased, the light will try to travel faster. So if here the velocity is small, but now after coming into A, the velocity got increased, so it will try to move ahead. So it is not, so we can say that it will divert or travel away from normal. Okay, so hope you understood what is refraction and what is refractive index formula, and how to no need to remember the values, but still they can say that I have a medium where the light speed is this much, and if they ask you what is the refractive index of it. So for this I will give a small demo question. If for example, if a light ray is traveling with 2 into 10 to the power of 8 meters per second in a medium, find its refractive index. Okay, so for this the formula is simple. Refractive index is equal to velocity of light in vacuum by velocity of light in that particular medium. So here velocity of light in vacuum we know, which is 3 into 10 to the power of 8 meters per second. So what velocity of light in this medium they have mentioned, it is 2 into 10 to the power of 8. So if I divide these two, 10 to the power of 10 to the power of cancel, meters per second, meters per second cancel, 3 by 2, which is 1.5. So the refractive index of the medium which they are provided is 1.5. Okay, so refractive index will not have any units. Why? Because both the units gets cancelled out and we will have only a number. It can be decimal as well. Okay, in this so I am concluding this video where I have covered the topics related to refraction. So in the next video, that is part 4, we are going to cover lenses, concave, convex. So we'll try to cover concave lens, convex lens, and try to have at least all the images found by convex lens. If possible, we'll cover concave lens as well. Okay, so we'll meet again in part 4. So mostly within next 3 days you will get the part 4 video in my channel. Okay, so if you like this video, please do like. If you have any doubts, if you want to share any feedback, I always welcome, and please comment in the comment section below. At the same time, if you want, I also keep the links of part 0, 1, 2 in my description. So if you want to refer those videos, you can check and let me know if you have any doubts on the same. Okay, so let's meet again in part 4 in the next coming 3 to 4 days. Thank you.